Hi all, my name is Ashwin Kannan. I'm part of the CSE548 Advanced Computer Network Security class for the Spring 2022 semester, and this is the video for the second project, that is SDN based stateless firewalls. Here we are creating an SDN based firewall, that is software defined networking firewall environment, using concepts like mininet, container net, box controller, etc. To regulate network traffic, The main part of this, the main feature of this SDN based firewalls is it has a controller which acts as a centralized unit where policies are defined and enforced. This virtual machine was created. Now let's move on to how the virtual machine was created. This virtual machine was created using using the media image shared by the professor. Hence, all the services like Mininet, etc., were already present. Hence, we can directly move on to getting the source code, downloading the source code, and unzipping it. So we download the source code using wget, and then unzip it using the unzip command. As you can see, the source code is downloaded and it was unzipped. This unzipped file consists of the layer 2 and layer 3 firewall configuration files, layer 2 and layer 3 firewall configuration files, and these files have to be copied to the appropriate path, that is in the box path. So we go to home, we go to Ubuntu, and in box we find the required L2 and L3 firewall configuration files. The next step is to run a box controller for 6655 and 6633, as this is essential for the firewall filtering. So for 6655, we run box. As you can see, it is up and running. And similarly for 6633 also, we run the box. As you can see, it is up and running. So now, as you can observe, we have started a box controllers. Now, as part of the first requirement, we need to create a mininet of 4 hosts and one switch Hence, to do that, we use the sudo mn command. We open a new terminal. There, we run the sudo mn command with 4 number of hosts is 4. We run this, put the password in. We see that 4 hosts, 2 controllers, and 1 switch is created. Next, second requirement is we have to assign hosts, IPs to each of the 4 hosts. So we assign 192.168.2.10 through 192.168.2.402 hosts ranging from H1 to H4. So we assign the first one using ifconfig. For H1, we have assigned H192.168.2.1. Similarly, for H2, we are assigned 2.192.168.2.2. Similarly for H3. Similarly for H4. Next, the third requirement is to block ICMP traffic from H1 to H3. That is from 192.168.2.10 to 192.168.2.30. Let us check by pinging it. We see that the packets have there's packet loss. There is a glitch, or there's an issue that I faced in this project. That is, first ping is all you never get 100% packet loss for the first ping. So when I do H1 ping H3, at this time I get 100% packet loss. Second step is we have to block traffic from 192.168.2.2 to 192.168.2.4. That is from H2 to H4. I do H2 H ping H4. You can see that there is 100% packet loss. How did we achieve this? We achieved this by appending the firewall rules. We open this. Since hosts are L3 problem, L3 issue, layer 3 issue, we open the layer 3 configuration file as follows. We observe that we have appended the first rule as 192.168.2.102, 192.168.2.30, and we have blocked ICMP traffic. Similarly, second rule is for 192.168.2.2 to 192.168.2.4, we have blocked ICMP traffic. Third rule we have appended is, as we'll be seeing, from 192.168.2.2, any and every TCP traffic is blocked. TCP/80, that is HTTP traffic, is blocked. The fourth rule is similarly from 192.168.2.1 to 2.20, that is from H1 to H2, TCP traffic is blocked. And the last rule is from H1 to H2, all UDP traffic is blocked. All UDP traffic is blocked. Now that we have observed that because of these rules, H2 flow from H1 to H3 and H2 to H4 is blocked, and we are facing 100% packet loss. So in the next step, we'll be seeing how we can block the HTTP traffic from 192.168.2.2. Now, to block HTTP traffic from H2 host, what we do is first we use exterm to open the H2 host and along with it any other host. So we open H1, H2. So next we write the following command to check the for the flow of traffic. Here we write in H1 we write this basically checks for HTTP traffic in host H1. Now that we have run this, we will run an nmap. We will basically run an nmap from H1 to check for traffic of 192.168.2.2, that is H2. When we run the nmap, we wait for the nmap to finish running. We run it again because we are getting some sort of a glitch. Nmap takes some time to run. We see that the traffic from MAC address 02, that is H2 host, is filtered. Next up, we have to block TCP traffic from host 1 to host 2, and then UDP traffic from host 1 to host 2. So for that, we use a simple line of Linux command to block the host TCP traffic from host 1 to host 2. So as we already seen, all the rules are appended in the L3 configuration files. H1 we use hping 3 command to block the TCP traffic from H1 to H2. As you can see now, this H1 to H2 TCP traffic is blocked because we have appended this rule in the L3 firewall configuration file. Now, similarly, we have to block UDP traffic from H1 to H2, that is from 192.168.2.10 to 192.168.2.2. So for this, we make a simple change to the TCP command. We remove the timestamp and replace TCP with UDP. When we do this, we observe that the packets have all failed and there is 100% packet loss. Hence, we have completed the TCP and UDP traffic block also. Finally, we have to block traffic from the MAC address of host 2 to MAC address of host 4. This is, since MAC addresses are involved, this is a data link layer problem. Hence, we have to involve the L2 firewall configuration file. To achieve this, what I've done is I have uh, to achieve this, I have first cleared all the rules in the L3 firewall configuration file. As you can see, I've cleared all the rules in the L3 firewall configuration file. Now I have gone to the data link layer, that is L2 firewall configuration files, and added the MAC addresses of the source and destination, that is H2 and H4. After this, I have made sure that I have gone to the gone to the Mininet portal and pinged from H2 to H4. As you can see, when we do this, we achieve 100% packet loss, and hence all the traffic from H2 to H4 is blocked. This completes all the requirements of this second project, and I have presented the same. I thank you all for listening to this. Thank you.